In this lesson, we're beginning our journey into geometry by learning the three most important building blocks: points, lines, and planes. Let's start with the simplest idea in geometry: a point. A point shows an exact location in space. It tells us where something is, but it has no size. Points are usually named using capital letters like point A, point B, or point C. So remember, a point is simply an exact location. A line is straight and continues forever in both directions. One important idea in geometry is that 2 points determine a line. In other words, if you know the location of 2 points, you can draw exactly one straight line that goes through them. Now let's move to the third big idea: a plane. A plane is a flat surface that stretches forever in all directions. A plane can be described using 3 points that are not in a straight line. When 3 points lie on the same flat surface, they help define that entire plane. So a plane is basically an infinite flat surface. Let's summarize everything we learned. A point shows an exact location. A line is a straight path that goes on forever. And a plane is a flat surface that also continues forever. As you know, a line is straight and continues forever in both directions. That means it has no starting point and no ending point. Now let's look at something slightly different: a line segment. A line segment has 2 endpoints. That means it starts at one point and stops at another point. So, unlike a line, it does not continue forever. When we name a segment, we use the 2 endpoints. So, here we call it segment AB. Another important idea is that segments have length. We can measure how far point A is from point B, and that distance is called the length of the segment. So remember, a segment is a piece of a line with 2 endpoints and a measurable length. Next, let's talk about a ray. A ray starts at one point, but instead of stopping, it continues forever in one direction. So it has one endpoint, and then it goes on without ending. When naming a ray, the starting point must always come first. So ray AB starts at A and goes through B, continuing in that direction forever. Let's compare all 3 ideas so the differences are clear. A line goes forever in both directions. A segment has 2 endpoints and stops. And a ray starts at one point and goes forever in one direction. Now we're going to learn 2 important geometry ideas: collinear points and coplanar points. Before we start, let's quickly review 2 ideas. A point is simply a location. It tells us where something is. First, let's talk about collinear points. The word collinear simply means points that lie on the same line. If several points all sit on one straight line, they are collinear. Here we see points A, B, and C all sitting on the same straight line. So we say points A, B, and C are collinear. Now notice this new point, point D. Point D is not on the line. So now, if we look at points A, B, C, and D together, they are not collinear, because not all of them lie on the same straight line. So remember, collinear means same line. Now let's move to the second idea: coplanar points. The word coplanar means points that lie on the same plane. A plane is a flat surface that extends forever in all directions, like a giant endless tabletop. Here we see several points sitting on the same flat surface. So we say these points are coplanar. They all lie on one plane. Now look at this new point above the surface. This point is not on the plane. So now all the points together are not coplanar because one of them is off the flat surface. So remember, coplanar means same plane. Let's summarize everything. Collinear points are points that lie on the same line. Coplanar points are points that lie on the same plane. We're going to learn how to find the distance between 2 points on a coordinate plane. Distance tells us how far apart 2 points are. And in geometry, we always measure distance in a straight line. So when we see 2 points on a graph, we want to know the length of the straight segment connecting them. Here we have point A at 1, and point B at 6, 4. And we want to find how far apart these 2 points are. To understand how we measure this distance, we use something you already know: right triangles. First, we move horizontally from point A until we line up with point B. Then we move vertically to reach point B. So instead of going diagonally right away, we move across and then up. This creates a right triangle. And the straight line distance we want is actually the diagonal side of this triangle. To find that diagonal length, we use the distance formula, which comes from the Pythagorean theorem. The formula tells us to subtract the x values, subtract the y values, square both results, add them together, and then take the square root. So the formula looks like this. Distance equals the square root of the difference in x values squared plus the difference in y values squared. Now let's calculate the distance step by step. First, subtract the x values, 6 minus 1. That gives us 5. Next, subtract the y values, 4 minus 1. That gives us 3. Now we square both results. 5 squared is 25. And 3 squared is 9. Next, we add those numbers. 25 plus 9 equals 34. And finally, we take the square root. So the distance between the 2 points is the square root of 34. And that is the exact distance between points A and B. Let's summarize the steps. First, subtract the x values. Second, subtract the y values. Third, square both results and add them. And fourth, take the square root. This formula works every time you need the distance between 2 points. We're going to learn how angles work and how we measure them. Let's start with the basic question: what is an angle? An angle is formed when 2 rays start from the same point. That shared starting point is called the vertex. So imagine 2 paths starting at the same place, but going in different directions. The space between them creates an angle. The amount of opening between those 2 rays is what we call the angle. So remember, 2 rays, 1 shared point, and the opening between them. Angles are measured in degrees. A full circle measures 360 degrees. If you spin all the way around and come back to where you started, you've turned 360 degrees. Half of a circle is 180 degrees, which forms a straight line. And a quarter of a circle is 90 degrees, which forms a perfect corner. So angles tell us how much turning or opening we have. Now let's look at different types of angles based on their size. An acute angle is smaller than 90 degrees. It looks narrow or sharp. A right angle measures exactly 90 degrees. You see right angles everywhere, in corners of rooms, books, doors, and screens. An obtuse angle is larger than 90 degrees but smaller than 180 degrees. It looks wide but not completely straight. A straight angle measures exactly 180 degrees. It forms a straight line. So angles are classified based on how wide they open. Angles also have relationships with each other. Adjacent angles are angles that sit next to each other. They share a common side and the same vertex. When 2 lines cross, they create opposite angles called vertical angles. These opposite angles are always equal in measure. So if one angle measures 50 degrees, the one directly across from it also measures 50 degrees. We're going to learn an important geometry rule called the Angle Addition Postulate. This rule helps us understand how a large angle can be split into smaller angles, and how those smaller angles combine to form the whole. First, notice point B. This is the vertex, which means it is the common starting point of all the rays. From point B, one ray goes toward point A and another ray goes toward point C. These 2 rays create a large angle. Now we draw another ray from point B going toward point F. This new ray lies inside the big angle. And when we place this ray inside, it splits the large angle into 2 smaller angles. So instead of one big angle, we now have 2 smaller angles that sit next to each other. The big angle formed between rays BA and BC is named angle ABC. When naming angles, the vertex always goes in the middle. So the middle letter B tells us where the angle is located. Now let's name the 2 smaller angles created by the inside ray. The first smaller angle between rays BA and BF is called angle ABF. The second smaller angle between rays BF and BC is called angle FBC. So the inside ray creates two adjacent angles. Now here's the important rule. The measure of angle ABF plus the measure of angle FBC equals the measure of the big angle ABC. In simple words, the parts add up to the whole. This is exactly what the angle addition postulate tells us. Notice how each part of the equation matches a piece of the diagram. One small angle corresponds to one part of the equation. The other small angle corresponds to the second part. And together, they equal the large angle. So the diagram and the equation are showing the same idea. Let's see a quick example. Suppose the first small angle measures 35 degrees, and the second small angle measures 50 degrees. To find the big angle, we simply add them. 35 plus 50 equals 85 degrees. Let's learn how to solve for a missing angle using the angle addition idea. First, focus on point M. This point is called the vertex because all of the rays start from this location. So everything we're studying today happens around this one point. Next, look at the two outer rays, one going toward point L and the other going toward point T. These two rays form the large angle. And we are told that this entire angle measures 39 degrees. So that is the total amount of angle we are working with. Now another ray appears between those two rays. This new ray goes from point M toward point S. And because this ray lies inside the big angle, it splits the large angle into two smaller angles. So now we have two smaller angles. One of them, angle LMS, is labeled X, which means its measure is unknown. The other smaller angle, angle SMT, is given as 12 degrees. So together, these two smaller angles must equal the big angle. Because the big angle is made of these two smaller angles, we can write an equation. The first small angle plus the second small angle equals the whole angle. So we write x plus 12 equals 39. This equation comes directly from the diagram. Now we solve for x. To isolate x, we subtract 12 from both sides. So we get x equals 39 minus 12. And 39 minus 12 equals 27. So the missing angle measure is 27 degrees. And that gives us the size of the unknown angle. Once you understand this process, solving angle problems becomes much easier. And you'll see this type of reasoning again and again in geometry. We're going to learn about complementary angles. The key rule is this: complementary angles always add up to 90 degrees. So let's look at some examples to see how this works. First, let's build a right angle. A right angle is the type of angle you see in the corner of a room or a piece of paper. And a right angle always measures 90 degrees. So this entire corner we see here measures 90 degrees. Now we draw another ray inside the corner. This splits the 90-degree angle into two smaller angles. So instead of one big angle, we now have two smaller angles that sit next to each other. The first smaller angle measures 30 degrees. The second smaller angle measures 60 degrees. So when we add them together, 30 plus 60 equals 90 degrees. And since the two smaller angles add up to 90 degrees, they are called complementary angles. So anytime two angles add to 90 degrees, they are complementary. Now let's look at another example. Again, we start with a right angle, which measures 90 degrees. And again, we split it into two smaller angles. This time, both smaller angles measure 45 degrees. So when we add them, 45 plus 45 equals 90 degrees. Since these two angles also add up to 90 degrees, they are also complementary angles. Now we're going to learn about supplementary angles. This is another important idea in geometry, and it appears very often when we study lines and angle relationships. Let's look carefully at the diagram. We have 3 points labeled A, B, and C. Point B is in the middle, and it is the vertex, which means it is where the angle is formed. From point B, one ray goes toward point A and another ray goes toward point C. Together, these two rays form a straight line. And whenever we have a straight line, The angle formed measures 180 degrees. So the angle from A through B to C, which we call angle ABC, measures 180 degrees. Let's practice solving problems using supplementary angles. Remember, angles that lie on a straight line are called supplementary angles. And supplementary angles always add up to 180 degrees. Let's start with problem 3. We see a straight line and another ray splitting that straight line into two angles. Because the angles form a straight line, they must add up to 180 degrees. One of the angles is given as 65 degrees. The other angle is labeled with the variable a, which means we need to find its measure. So we write an equation using the supplementary rule. 180 minus 65 equals 115. So the missing angle measure is 115 degrees. Now let's move to problem 4. Again, we have angles forming a straight line. So again, the angles must add to 180 degrees. This time, one angle is 128 degrees, and the other angle is labeled with the variable z, which we need to find. 180 minus 128 equals 52. So the missing angle measure is 52 degrees. And supplementary angles always add up to 180 degrees. Once you recognize straight line angles, solving these problems becomes very easy. Great work, and we'll keep building on this in the next lesson. Now we're going to learn about vertical angles. This is one of the most important angle relationships in geometry, and once you understand it, solving many angle problems becomes much easier. Vertical angles appear whenever two lines cross each other. When two lines intersect, they create four angles around the intersection point. Now look carefully at the angles that are directly opposite each other. These opposite angles are called vertical angles. They are not next to each other. They are across from each other. And here is the most important rule. Vertical angles are always equal. No matter how wide or narrow the lines cross, opposite angles always have the same measure. Let's look at our first example. One of the angles measures 70 degrees. The angle directly opposite it is labeled with the variable x. Since vertical angles are equal, x must also measure 70 degrees. So we conclude that x equals 70 degrees. Now let's look at another example. This time, one angle measures 120 degrees. The opposite angle is labeled with the variable y. Again, since vertical angles are equal, y must also measure 120 degrees. Whenever two lines intersect, opposite angles are called vertical angles. And vertical angles are always equal in measure. Now we're going to study something called a linear pair. This idea connects directly to what we already learned about supplementary angles and straight lines. A linear pair happens when two angles sit next to each other and form a straight line. In other words, the angles share a common side, and their outer sides form a straight line. Here we see a straight line and another ray coming out from the same point. This creates two angles right next to each other. These two angles share one side, and their other sides form a straight line. When two angles form a linear pair, their measures always add up to 180 degrees. So linear pairs are always supplementary angles. Let's look at our first example. One of the angles measures 65 degrees. The angle next to it is labeled x, meaning we need to find its measure. Because these two angles form a linear pair, they must add to 180 degrees. So we write the equation. To find x, we subtract 65 from 180. That gives us 115. Now let's try another example. This time, one angle measures 128 degrees. The angle next to it is labeled y. Again, since they form a linear pair, they must add up to 180 degrees. To solve, we subtract 128 from 180. That leaves us with 52. So the missing angle is 52 degrees. Let's summarize what we learned. A linear pair occurs when two angles sit next to each other on a straight line. And angles in a linear pair always add to 180 degrees.